All right, Mike 102, lecture 2.1. The question is about proving that a function is increasing, decreasing, and constant. So let me first of all prove you that a function is increasing. You have two options for you. If you are graphing your function, and let's try to graph the function f of x equal 2x plus 1, you are going to have the y-intercept is 0, 1, and if you're not following, just let me know. So your y-intercept is going to be 0, 1, and because the slope m equal 2, which is 2 over 1, I need to go up 2, and I need to go right 1 from the y-intercept. So 1, 2, right 1, and that is my line. All right. When you graph that line with your calculator is going to graph the line like this. So it's kind of very intuitive to say, well, okay, my line is increasing. This function is increasing. On which interval? Well, on the interval negative infinity plus infinity. Okay, the interval defining all the value of x that you can read, that is where it's increasing. And it's increasing from minus infinity, negative infinity to plus infinity. It's fine?
Yeah.
Now you can prove that also by saying this. Let's say you are taking two value of x. I'm going to take this value of x right here. Actually, I'm going to take another one. Sorry, I'm going to take another one. So I'm going to regraph that. There we go. I'm going to take... Okay, so I'm going to take this value right here. This is x1. Defining with a value y1, and I'm going to take another value which is going to be right here. Okay, this is y2, and that is x2, correct? Mm-hmm. Okay, if I look at these 2 points, if I call the point number 1 and the point number 2, I see that my point number 1 is defining by the coordinate 1 when x equal 1, I end up to have y equal 3, and the point number 2 is defined with the coordinate 2, 5. Okay?
I'm confused.
Because when x equal 2, 2 by 2 equal 4, plus 1 equal 5. Okay? I just wanted to have numbers. This is why I put numbers. Then I'm going to do it without any numbers. What do I see? I see right here that x1 is less than x2. And I see also that f of x1, which is equal to 3, is less than f of x2, which is equal to 5. You following?
Mm-hmm.
I got x1 equal 1 is less than x2 equal 2. When you have x1 less than x2 and f of x1 less than f of x2, you end up to say that your graph is increasing. Your function is increasing. That means the function of x is increasing. You with me?
Mm-hmm.
All right? So that is how I prove. If I just decide to say, if I have a function with 2 points, x1 less than x2, I'm going to have f of x1 less than f of x2. That means my function is f is increasing. Now, let's imagine that now you understand that if I graph another line and now this line is going down, your graphic calculator is starting from the top left and going down. You're going to say, oh, it's decreasing. It's natural. Okay, your graph is going to do this way, decreasing. You with me?
Mm-hmm.
Okay. Now, if I apply exactly the same thing, I take 2 points. I'm going to take this point right here and I'm going to take this point right there. I take this point, I'm going to call this point x1, and I'm going to call this point x2. Each of these points will be defined by f of x1, which is y1, and this point right here will be y2 equal f of x2. You with me? Mm-hmm. All right. When I look at this point, I can sincerely say that x1 is greater than x2. Do you agree? Because x1 is positive and x2 is negative. So obviously x1 is greater than x2.
Okay.
When I look at the value of f, what do I see? I see that f of x1 is less than f of x2. Do you agree? f of x1 equal 1 when f of x2 equal 3.
Yes.
So that implies your function is decreasing.
Okay.
So if you're asking me on the lecture note 2.1 practice problem, where do I read where it is increasing, decreasing? Just looking at the graphic, you can tell where it's decreasing and increasing. Okay, if you look at the problem number 1, on the problem number 1, you are going to say the function f is decreasing on the interval 0 bracket. Why a bracket? Because you have a solid dot on the x equals 0. You have a solid dot right here. Okay, up to x equals 3, but it's a parenthesis. Why? Because there is an open dot regarding the point when x equals 3. Then you are going to say between f will be increasing when you are starting from x equals 3, but because there is an open dot, you're going to have parentheses, open dot, up to x equals 4, bracket, because of, and the other one is going to be f is decreasing from 4 to 6, bracket, because both of them are defined with a solid dot. Now, if you ask, and it's visually easy to define where it is going up and going down. Now, if you're really insecure, what you will have to do is exactly what I did right here to prove you that this part of the graph is increasing or decreasing. If you look on the interval 0, 3, you take 2 points, and if you take the point, let's say the point number 1, so if you look at your graph right here, right now, let's say you are doing this, you have a solid dot right there, an open circle right here, this is 3, 2, 1, and this one is negative 1. Well, you are going to take 2 points. Let's take the point right here. X equal 1, let's be roughly, we're going to say negative 2. And if I look at x equal 2, I'm going to be below, and it's going to be negative 3. What do you see? You see that for the point number 1, you have coordinate 1, negative 2. For the point number 2, you got the coordinate 2, negative 3. What do you see? You see that the point number 1 is less than the point number 2. So x1 is less than x2, 1 is less than 2. But
y is greater than
f of
x
1
or y.
is greater than f of 2. That means it's decreasing. So you proved that it was decreasing on this interval. That implies, okay, my function is decreasing.
Okay.
You okay?
Mm-hmm. We understand that a lot better.